This is investigation 2.4, summary part B of frogs, fleas, and painted cubes. So in this problem, we're being asked to describe the graph of each of the equations, as many details as possible. So we are going to be looking at the intercepts, well, such as the intercepts, anytime. Oh, please don't crash. Please, oh, there you go. Okay, so we're going to be talking about the intercepts, maximum or minimum, the line of symmetry, and I'm going to include one other thing, whether it is opening up or down. Maybe it'll show, oh, look at that chicken scratching, nice. Oh my god. And we're crashing. Maybe. Nothing worse than making. Now, a parabola that's opening up is looking like a U. If it's opening down, it looks like a frowny face. So this is down, and this is up. All right? Okay, hopefully we're all good now. So let's take a look at V1. We are being asked to find the x-intercepts, the y-intercept, the line of symmetry, and the vertex, whether it's a maximum or minimum. And so here we go. The x-intercepts are in the factored form. The y-intercept is in the expanded form. And I can see this clearly as expanded because there are no parentheses. So therefore, my y-intercept is going to be 12. 12. Now we need to factor this. Now, there are a couple ways you could do this. You can make your divided rectangle. And we could say this is 12. 12. This is x squared, so that we have x. Wait for it to process. X. And so we're looking for two numbers that multiply to 12 that add up to 8. Well, we know 6 and 2, right? So 6, maybe, just maybe. 6 times 2 is 12, where 6 plus 2 is 8. So then that means we have y, no, that's an x. Y is equal to x plus 6 times, there we go. Oh my god. X plus 2. All right, so we know at the x-axis, well, the y value is 0, so we know y 0 is going to equal x plus 6. And we also know that x plus 2 could also equal 0. Well, subtract 6. Subtract 6. So we get negative 6 is equal to x. Over here, minus 2. And wait. It may or may not work. We'll find out. Okay. Minus 2, and we get x is equal to negative 2. So there we for our intercepts are at negative 6 and negative 2. All right. Now, the number in between negative 6 and negative 2 is negative 4. And so we know x equal to negative 4 for your line of symmetry, which means for your vertex, negative 4 is going to be your x value. That is your abscissa. Woohoo! Obscure vocabulary. And now let's plug in negative 4 into our equation. So we have negative 4 plus 6. We're going to multiply that by negative 4 plus 2. Well, negative 4 plus 6 is 2. Negative 4 plus 2 is negative 2. So we get a grand total of negative 4. Now, for opening up and opening down, it's very, very basic. This is called the quadratic term. I'm not going to write it because it's not going to like it. I'll just put a big Q for quadratic. Now, your quadratic term determines whether a parabola is opening up or down. If your quadratic term is square, of course it's squared. If your quadratic term is positive, it is opening up. So therefore, this is opening up, which means we're going to have a minimum point, not a maximum. in contrast, if your quadratic term is negative, it's going to open down. So if we had a negative x squared, we know it would be opening down. And so this is called the linear term, because if you were to graph this by itself, you get a line. And this is called the coefficient, because it does not change. Or it's also, sorry, it's not the coefficient. Step back, nope. It's the constant, because the constant doesn't change. This is 8 is the coefficient of the linear term, so I'm sorry about that. This is the constant. All right, so let's take a look at B2. Maybe, just maybe, if my computer doesn't freeze. All right. All right, so now we have a factored form expression. And so in my factored form expression, I know I'm going to have to set this equal to 0. So plus 3, so x is equal to 3. And over here, minus 3, and I get negative 3 is equal to x. And right now, you should look at this and say, oh my goodness, this is a difference of squares, because the values inside the parentheses are all the same. The only difference is the adding and the subtracting, difference of squares. All right, so our x-intercepts are negative 3 and 3. My y-intercept is in the expanded form. So if I multiply this out, I know when I multiply a difference of squares, the linear term will cancel out. So all I have to do is multiply the x's, so I get x squared. Negative 3 times negative 3 is negative 9, a difference of squares. Difference being subtraction, squares being two terms that are perfect squares. All right, so what is my y-intercept? Well, here is my constant term, which is my y-intercept. Now my line of symmetry is going to be in between negative 3 and 3. Now the line of symmetry for all differences of squares is going to be 0, because difference of squares will give you an x-intercept that is always there, that are always opposites. And so since your line of symmetry is on the y-axis, you know that your minimum, maybe, just maybe I'll get an M here. Please don't crash now. I know at home the thing that you enjoy about these videos most is watching and rooting for my computer to crash, but it's really not much fun here. So my minimum is going to be 0, negative 9. Now, is this opening up or down? Well, in the expanded form, my quadratic term is positive, therefore it's going to be opening up, and it's going to look something like this, where this is 4, this is negative 4, and this point right here is 0, negative 9. All right, one more. Maybe we can get it done without major disaster, although right now my hopes are not high. All right, last one. Oh, look at that. So we have another expanded form expression. I know it's expanded because there are no parentheses. So we know we have y is equal to, the x-intercept and y-intercept. And right now we're adding nothing right here, so I know my y-intercept is going to be 0. This is going to go through 0, 0, which incidentally means it's probably going to, well, we'll get there. So when it comes to factoring, I'm looking at this term, and I'm going to go through my factoring checklist. The first thing I look for is the greatest common monomial. Well, is there something that goes into all of the terms? In this case, the answer is quite obviously yes. We have x's in both of them. So I'm going to do something a little bit freaky here. I'm going to factor out a negative x. Why negative x? Because I want my x to be positive in the parentheses. Why? Because I do. So negative x squared divided by negative x is just x. 6x divided by negative x is negative 6. So here is my factored form expression. And let's take a look at this. If I were to cover up this piece let's stick with the breaking apart idea. So let's break this apart, set each side equal to 0. So I have negative x is equal to 0. Oh, what's x equal to? X is equal to 0. So one of my x-intercepts is 0 because what will make this piece 0? 0. Over here, let's add 6, and we get x is equal to 6. So my line of symmetry is going to be between 0 and 6, which is 3. And, sorry, my vertex, in this case, is going to be a maximum, is going to occur at 3 comma something. And to figure out the something, I must plug this in. So I have negative 3. Why? Because now I'm finding out what the y value is when x is 3. Times negative 3 minus 6 is equal to y. So negative 3 minus 6 is negative 9 is equal to y. And so y is equal to positive 27. Now, I said this was a maximum. How did I know? I knew this was going to be a maximum because the quadratic term is negative. Therefore, this parabola will open down, which looks like this. And if I were to graph this fun thing, I would end up with, oh, that's a little too off for my taste. Anytime. So my x-intercepts are here at 0 and 6. Here's my line of symmetry at x equals 3. Sorry. And my maximum point right here is 3 comma 27. All right, so there you have it. Plus some extra bonus graphs to boot.